Okay, so we're going to use a shell method to revolve this area bounded by y, which equals x squared, x, which equals 2, and the x-axis. So about y, which equals -2. Okay. We've actually already done this problem. We have 1 and 2, and then 1, 2, 3, 4. Okay. That's y, which equals x squared, x, which equals 2, and the x-axis about the line 1, 2. Okay. Then we go down 1 and 2. And 1, 2, 3, 4. Right there. Okay. So this is basically what we're trying to revolve, except it's got a hole in the middle. And I'll kind of leave it at that because otherwise it starts to look really, really messy. Okay. Now, when we did this before, when we did this with a disk method, okay? Right now, doing this as a disk method, we said, okay, well, I'm going to increase. All right, so remember, with the disk method, it's pi r squared. Okay? And so you can think of it as one way as shifting up, or you can think of it as, well, why don't I add 2 to the radius? Okay? And so when we treat this as the shell method, we're going to do, well, the same thing. We're going to end up adjusting the radius. All right? So what we're going to get from this, though, is, all right, so if I start drawing shells on this thing, shell out to here. Okay. And let me just go backwards. We're going to have our shells expand in the y direction. Okay. But what is that going to give me? That's going to give me some type of weird shape. What am I trying to get out of this? I'm trying to get, all right, this is what we're trying to get. This type of shape right here. Okay. So we're trying to get that shape. Okay. So actually reminds me of a Kunta, or it was a tool that was used. And so if I look at the walls of my shell, now the walls of the, okay, sorry, I dropped the microphone. Sorry about that. So the walls of the shell, that's what we need to be looking at. And wondering, well, what are the walls of these shells really creating? Well, this right here, if I look at it, I would say, what is this giving me? This is giving me, okay, so the walls are over here. Okay. So since the walls of the shell are extending out from the y-axis, okay, that is definitely not the volume that I'm looking for. So what can I do I could say, well, if I want to use a shell method, okay, so that's what I'm getting. Well, why don't I take a big cylinder, it's already got a hole in the middle, just a little bit bigger. And then if I subtract out that volume that I'm getting right there, okay, so something like that. And then that will end up equaling so we got the hole in the middle. Okay. So if I can formulate these two problems and subtract them, then it's going to end up giving me the volume that I'm actually looking for. Okay. So, but how to do this? Okay, so if I just start talking about this volume right here, right? So what's going to happen with that volume right there? So if I take cylinders and I start adding them up, well, if I talk about, all right, the height of the cylinders is going to be a constant. The height of the cylinders is going to be 2, okay? But the radius of the cylinders, if you imagine it, the radius of the cylinders are going to begin at 2, and now it's going to go all the way out to 6, okay? But how do we represent that? So for this first guy right here, let's fold this over for right now. Okay. Now, when you do this, this is going to have to be an integral from 0 to 4 because we're integrating in the direction of y. Okay. Now, for this first one right here, this is going to be 2 pi and then y plus 2 times 2 dy. All right. And this is my radius and this is my height. Okay. So when I change the radius to y plus 2, what does that mean? When I plug the boundary of 0 into this, I'm going to get the radius to be 2. And when I plug the boundary of 4 into this, what am I going to get? I'm going to get a radius of 6. Okay. So you imagine your cells begin at a radius of 2 and go out to 6. That's what the boundaries are telling you. All right. And then we have to subtract out this guy. Integral from 0 to 4. This is 2 pi. And then y plus 2. And remember, y equals x squared, so x is going to equal the square root of y. So that's going to be root y dy. Okay? And so, what's this going to come out to? Let's do a little bit of simplification. Becomes the integral from 0 to 4. All right, 2 times 2 is 4. That's 4 pi y. 2 times 2 times 2, that's 8 pi. dy, okay, and then minus the integral from 0 to 4. That's going to be 2 pi, now y to the 3 divided by 2, and then plus 4 pi y to, well, 1 over 2. It just square root of y, but I didn't leave enough room, so we'll leave it like that. Okay. So these are the two things that we're going to evaluate. And so, okay, so what is this going to become? This is going to become 4 pi, now y squared divided by 2 plus 8 pi y, evaluated at 0 and at 4, and then minus, we'll do it like this with some parentheses. Let's say 2 pi, and then this becomes y to the 5 divided by 2, divided by 5 divided by 2, plus 4 pi, y to the 3 divided by 2, divided by 3 over 2. Let's close those parentheses. And this one also has to be evaluated at 0 and at 4. Okay. All right, 8 times 4 is 32. Y squared is 16. 16 divided by 2 is 8. And so this ends up becoming, this is 32 pi plus 32 pi minus, we could write this as 4 pi divided by 5 times 4 to the 5 divided by 2. And then minus, that would be 8 pi divided by 3, and then 4 raised to the 3 divided by 2. And we don't care about the 0 terms, but at this point of the problem, I mean, if this was a test and you were working out in one of my classes and you wrote this down as the answer, I would mark this as correct because it is correct, but you just didn't do all the simplification.